Good afternoon, everyone, and welcome to our 2:30 Behind the Headline presentation here at the Gordon Current Science and Technology Center. Every day at 2:30, we share a Behind the Headline presentation that delves a little more deeply into the science behind some of the stories that you may have seen or read about in the news. At the end of each year, the current science and technology staff get together and we vote on what we think were the 10 most impactful or important science stories of the previous year. And that's what I'm going to be sharing with you today. Now, our first story is actually an honorable mention. The fact that we're all still here, we survived the end of the world on December 21st. And for a while, there was concern about the December 21st end of the Mayan calendar. But it turns out that there's no evidence in the Mayan records that indicated they thought any kind of apocalyptic event would happen. The calendar is just based on a complex mathematical system that's circular in nature. So at the end of one calendar, a new one just begins, just like with our own calendar. On December 31st, we don't worry about the end of the world. We go out and buy a new calendar on January 1st. An entertaining moment in pseudoscience. So our real number 10 story is the 3D printing revolution, which is actually not brand new technology. It's been around for a little while, usually made to make prototypes of things. But there have been a lot of advancements in 3D printing. The technology is getting a lot better. It's really going mainstream. It's becoming more affordable. And for all of those reasons, we selected it as our top 10 story. So I mentioned we used to make prototypes with it, but the technology is advancing, so now we can make more durable, long-lasting, robust things with 3D printing, and it's actually used quite a bit in manufacturing these days. For example, some of your car parts are 3D printed. Now we have some artifacts here, 3D printed with plastic on a machine similar to what you see up here, the MakerBot 3D printer. So what you do is you take a 3D computer design, it's loaded into the printer, and it lays down thin layers of a material, layer after layer after layer, building up a 3D item. Now we can print 3D with paper, with plastic, with metal, and actually there's been a lot of advances in using 3D printing in medicine. The picture you see up here on the top left is a 3D printed jawbone that was implanted into a patient last year, and up there in the center shows some of our attempts to 3D print functional biological materials printed with live cells. We've already printed blood vessels and heart valves, and we're moving towards being able to print a 3D functional organ. Now, our number 9 story is the explosion of social media. Now, how many people here are part of some kind of social network or use social media? A lot of us do. And this year in October, Facebook hit 1 billion users. Now, this is not a new trend. The reason it made our number 9 story is because it really gained a lot of traction as it relates to science. There's been a huge growth in the number of published research articles in psychology and sociology looking into how social media affects our behavior and our relationships. One study looked at how social media affects large-scale behavior like voting. Now, we're also starting to use, or I should say researchers are starting to use social media as a data gathering tool, not just looking at how it affects our behavior, but actually looking to do science with social media. They're able to reach thousands or even millions of subjects using social media and gather a tremendous amount of data for research. The Department of Homeland Security is starting to use social media to track disease outbreaks. And physicians, 1 in 4 physicians uses social media on a daily basis or multiple times a day, not just to access medical information, but also to share and disseminate it a lot more quickly than they could otherwise. So it's really changing the world of science. Our number 8 story is about a 2009 earthquake in Italy. Late in April, in the middle of the night, there was a 6.3 magnitude earthquake in this area of Italy, and more than 300 people died as a result of that earthquake. Now, in 2012, in the fall, 6 seismologists and a government official were actually convicted of manslaughter in an Italian court. They face years of jail time and fines. And they are held responsible for the deaths associated with this earthquake. How does how does something like that happen? So to give you the backstory on this, early in 2009, there was a great increase in seismic activity in this area of Italy. And the public was starting to get very nervous. So the government officials in this area called a meeting where they invited seismologists to come and talk about the risks and probabilities of a larger earthquake from these small tremors they'd been feeling. The results of that meeting were never really made public. Really, what was covered by the press was a press conference after the meeting where one of the government officials made this statement. The scientific community tells me there's no danger. To the contrary, it's a favorable situation because there's a continuous discharge of energy. None of the seismologists actually believe this statement to be true. The science shows that there's no way we can predict an increase in probability for an earthquake from small tremors. We can't predict when these large earthquakes will happen. But none of the seismologists refuted that government official on camera. They didn't refute that statement publicly, and as a result, they were held accountable. Now, this is really a very tragic circumstance of the failure to communicate the risks associated with natural events, and it really makes us question who should be held responsible. Can we hold anyone responsible for these cases of unpredictable natural disasters? In the last few years, there's been a tremendous amount of research in the field of nanomedicine. But it takes a lot of time and money for nanomedical technologies to make it through the FDA approval process. And as a result, none of them are really being used with patients right now. We picked this particular story, this targeted nanoparticle cancer treatment, as one of our top 10 science stories because this year they showed positive results in human clinical trials, and they are one step closer to FDA approval and widespread use with patients. So this particular technology uses a nanoparticle designed by a local company called Bind Biosciences. They were founded by an MIT and a Harvard professor, Robert Langer and Omid Farrokhzad, and they designed this nanoparticle to target cancer in a special way. We can think about nanoparticles kind of like this toy, but a million times smaller, and they have all these attachments on the outside. So with this particle, the blue attachments are targeting molecules, ligands that help that nanoparticle find the cancer tumor. They act a little bit like a homing device. The gray molecules are a protective layer, kind of like a stealth coating to help that nanoparticle evade the body's immune system, let it stay in circulation longer, and give it more of a chance to find the cancer tumor. And finally, inside, we have a controlled release chemotherapy. Now, this is a chemotherapy that we use right now to treat cancer, but in the nanoparticle, it's delivered in a much more targeted way, and we also control when it's released. It's released more slowly, so more of it will be released at the site of the tumor once the nanoparticles find it. The picture you see on the left is a prostate cancer cell, and those pink clusters are clusters of nanoparticles that preferentially accumulate at the site of the tumor. So you can see that those nanoparticles do find their way to the tumor. So I mentioned that they had positive results in human clinical trials. This treatment was found to shrink tumors using lower doses of chemotherapy and fewer side effects, and it actually showed to be effective across a wide range of cancers, including some cancers that this particular chemotherapy is not often effective against. So it's very promising results. They're moving towards phase 2 clinical trials with a larger group of patients, and hopefully we'll keep moving through the FDA approval process and be used soon. Our number 6 story is climate change. And I have to admit that climate change is almost always in our top 10 science stories because it is such an important story that affects all of us. Now, the reason it made the cut this year is there were a number of climate change records that were broken this year. 2012 will be the warmest year on record in the United States. It will rank in the top 15 globally. And another interesting record has to do with sea ice extent. So up here near the North Pole over the sea, there's not a lot of, in the North Pole around this area, a lot of sea ice builds up. And it varies in extent. There's more in winter, some of it melts in summer. But in 2012, we saw a record low in the sea ice extent in September of this past year, really showing an alarming trend that in the summers more and more sea ice is melting and we're seeing less and less of it. That's an alarming trend, along with carbon dioxide emissions, which is implicated in our climate change. In 2012, 36 billion tons of carbon dioxide were released into the atmosphere. That is a record high. So a lot of these alarming trends we're seeing year after year increase, confirming that our climate is indeed changing. Our next top 10 story has to do with sequencing DNA. And there is a huge amount of data stored in your DNA, 3 billion base pairs. And sequencing DNA is a very time-consuming, expensive process. When we first did it, it took a decade and billions of dollars. There's been so many technological advancements. These days, we can sequence DNA for a few $1,000s, and we can do it in days or even hours. Now, one of those technological advancements is shown here on the left, nanopore sequencing. The idea with nanopore sequencing is you take a very thin membrane that conducts electricity. There's a tiny nanometer-sized pore in that membrane that we pull single strands of DNA through. Now, as the DNA passes through it, there are very slight changes in the electrical current running through the membrane. And by measuring those tiny variations, we can tell exactly which base pair is passing through the membrane at any given time, letting us very quickly and very easily sequence long strands of DNA. So, sequencing DNA lets us collect a lot more data. What are we doing with that data? Well, there is a new data gathering project called ENCODE, the Encyclopedia of DNA Elements. And what they've been trying to do over the last couple of years is figure out the biological function of the DNA sequence. And previously, we thought only a couple % of our DNA actually coded for proteins. The rest was labeled junk DNA. They thought it didn't really do anything because we didn't know what it did. But this project, which has hundreds of researchers around the world participating and sharing data, they figured out that large portions of what we thought were junk actually do have biological function. They promote genes, they regulate them, and it's really shed some interesting light on how intricately complex our genome actually is. Now we're getting down to our top stories. Our number 4 is Superstorm Sandy, which I'm sure you remember. This past fall, in October, Superstorm Sandy made landfall right around Atlantic City with sustained winds of 80 miles per hour, which made it a Category 1 storm. Now, even though it was just a Category 1 storm, it will go down in history as one of the most destructive storms to ever hit the United States. Now, the reason it was so destructive had to do with its incredible size. This storm was 1,000 miles in diameter, and it hit a very highly populated area, which is how it ended up causing billions of dollars of damage, leaving 8 million people without power. So this giant storm is able to push a huge amount of water towards the shore, causing record storm tides. 14-foot storm tides in New York City. They were measuring 32-foot waves in New York Harbor. Now that caused the New York City subway system to flood, along with a tremendous amount of other damage associated with flooding. Now, another aspect that made Superstorm Sandy so destructive was that it wasn't just a tropical system. It actually had elements of some other storm systems involved. It had some characteristics of a nor'easter as well as a tropical system. And with those characteristics, it made it so destructive. Coming down to our top 3. Our number 3 story is about a multi-state fungal meningitis outbreak, which is very, very rare, and it was traced back to a series of contaminated steroid shots that came from a Massachusetts pharmacy. So what happened here, fungal meningitis is an inflammation of the meninges, this protective covering around the spinal cord. It's also a protective covering around the brain. Here I have an animal brain that still has the meninges, that white covering on it. Now, when that protective coating gets infected with something, it inflames or it swells up, causing meningitis. Now, what happened with these contaminated steroid shots is, I'll show the video one more time. Oh, sorry, I'll go back. So what happened with these steroid shots is steroids, which are a powerful anti-inflammatory, are injected into the fluid-filled space right around the spinal cord. And these contaminated steroids actually had fungus. They had black mold. And all of these contaminated steroids came from the New England Compounding Center, which is located in Framingham, Massachusetts. Now, how does something like that happen? How does black fungus get in steroids? Well, the New England Compounding Center had unsanitary conditions. They broke a lot of rules. They were making much larger batches than they should have been. But actually, they're not the only ones to blame, because there were some really critical failures in oversight, both at the state level and at the federal level. And hopefully, we have learned a lot of lessons that will prevent a tragedy of this scale from ever happening again. From several thousand contaminated shots, there were several hundred cases of fungal meningitis, and it led to dozens of deaths. Our number 2 story is the Mars Curiosity rover. Now, you probably remember back in November of 2011, we launched Curiosity towards Mars. In August of 2011, Curiosity landed in Gale Crater, which is a crater just south of the equator of Mars. And what was really remarkable about Curiosity was its incredibly complex landing mechanism that we had never before tried. So this complex landing system involved a parachute to help slow the rover down. And beyond the parachute, though, it also had something called a sky crane, which further slowed down the rover and actually helped very precisely land it in a particular location right in Gale Crater. So it was incredibly complex and actually very, very successful, and was much better than the way we've landed things in the past, which is basically surrounding it with airbags and letting it come to a bouncing stop. So this was really a miraculous technological feat. Now, beyond that, once Curiosity landed, it was able to instantly send back some really incredible footage or collect data from Mars. It sent back the most beautiful images of the Martian landscape. It started doing tests on the geology and on the climate of Mars. It's collecting data. It's looking for evidence of biological life, or that the area of Gale Crater could possibly have supported microbial life at some point. It's looking for proteins and amino acids. It's testing for the role of water on Mars, and basically judging its habitability and its potential for human exploration in the coming decades. Curiosity was initially set for a 2-year mission on Mars, and that has been extended indefinitely because it's been so successful already. It has a nuclear plutonium fuel source, and as long as that fuel source lasts and it doesn't have mechanical breakdown, Curiosity could be running for the next 50 years. And finally, that brings us to our number 1 story. Are there any guesses from the audience what that story might be? You are absolutely right. The Higgs Boson, a massive discovery. Back in July of 2012, researchers from the Large Hadron Collider, a huge atom smasher in Europe, announced that they had found convincing evidence for the Higgs boson. Well, what is the Higgs boson? It is the particle that is theorized to give all other particles mass, which is very, very important. We have a lot of theories about the laws that govern the universe, and there was one missing critical component. How did everything get mass in the first place? About 50 years ago, a theory was put forth that the Higgs field explained how everything got mass. So let me give you a quick demonstration of what I mean. So after the Big Bang, all these particles were created, and they were zooming around, basically massless, moving at the speed of light. Until 1/1,000,000,000th of a second after the Big Bang, these particles interacted with the Higgs field, represented by sand. So when these particles interacted with the Higgs field, some of them interacted with it a lot and got quite a bit of mass. Other ones interacted with it only a little bit and got a little bit of mass. And the rest of them didn't interact with it a lot at all and remain massless. Those would be photons. So this interaction with the Higgs field explains how everything got mass, and that's why researchers are so excited about this discovery. because it answers these fundamental questions about the laws that govern the universe and help fill in these missing pieces about the forces that govern all of us. Now, let me go back to the main slide. So that is our #1 story, the Higgs Boson discovery, and that sums up our top 10 list for 2012. I only spoke about each one for a minute or two. I couldn't get into a lot of detail. So if you'd like to find out more, please stick around, chat with me. I'm happy to discuss these further. Also, if you'd like to hear more about what the current science and technology staff is doing, I encourage you to follow us on social media. The Museum of Science website has a podcast that details our top 10 science stories, and we also frequently post on Facebook and on Twitter, so please do follow us and hear more about current science and technology at the Museum of Science. Thank you so much, and I hope you enjoy the rest of your day here at the museum.